So, extensions functions in Kotlin, extension-oriented design, which is pretty popular in all the libraries on the language itself. So we're gonna learn what the hell is extension functions, right? So let's do an example here. Exercise 1. Write an extension function called isPositive that takes an integer and checks whether it is positive. So there are two concepts that we need to take into account, which are very important. What means object receiver and what means receiver type. But why on the world are we calling this object and receiver? Well, let's think of this way. One is just an instance of int, right? Because it's an integer. So for that reason, it's an object because it's an instance. And receiver is because isPositive is going to receive this, right? isPositive is an extension function. By default, we have like a many, right? In strings, two strings and all of that is maths and whatnot. But right now we're gonna create this extension function. So the way to create is to put first the reserved keyword font, the receiver type, and then you're gonna put the extension function name is positive, right? Is positive is not going to receive anything. I'm gonna show you how to receive this one, but it's just going to return a boolean, right? Returning a boolean. This is a type boolean. We're checking if it's positive or not. Now the meat and potatoes here to retrieve my one is just by using these. So rule of thumb is that everything which is on the left side of the dot is received actually by these, right? So these or one is greater than 0. Now if we run this code, it's gonna say true, right? But if I say this is gonna be false, right? Now in the function body we only have this statement, which is pretty short. We can make it more concise using just equal this and greater than 0. That's it. That's the beauty of Kotlin, and it's basically the same. Now we can also receive parameters. Let's say I want to check if a number is greater than another number. So I just want to say is greater than number, which is type of int, right? I just create, I can even create like another one actually. I can create another extension function so you guys can see it's greater than my number, which is an integer, and then that will do it, right? And these extension functions can pass a parameter. So this is gonna read on the left, and of course those parameters whatever you pass as an argument. So I'm gonna put is one greater than, let's say, 3, and if I run this, it's gonna be false. 1 is not greater than 3, but I believe 100 is gonna change the history, right? Right. Quickly, let's go to exercise 2. Write an extension function to call to lower a string that takes an string and returns an lowercase version. So the same. This object receiver, right, is an instance of the type or class string, which is called the receiver type. Now we are creating the extension function, right? We are not passing any argument. We are returning a string. We can use the shorthand, right? We can say just this, that, name of the function. I believe is lowercase. This is already out of the box by default extension functions we already have, right? Then if I run this, this is gonna be lowercase. Yeah, these are pretty baby steps of the extension functions, and it's pretty useful in libraries. It's very popular and wide used. It's very widely used. It's pretty good with extension-oriented design because you have useful functions, but you don't alter the core functionality, right? It's non-essential. It's easier to read. Let's say you have like a library that makes HTTP requests, and the main method is request, right? So you are creating get and post extension functions, so you don't have to write and pass all the parameters over and over again, because the most popular methods are get or post, and you have to use them constantly. So yeah, you just create those extension functions. Then this is the code. This is gonna be the receiver type, HTTP client, the request method, right? And then you just create a extension function. You just pass the URL, and you know it's a get request, right? You pass the URL and empty map. If you wanna create like a post, I can modify this. Okay, but basically you just put here post and post. You can expect like a map as well, right? Anyway, now you just create the instance. You can do the get request directly, right? But it looks pretty if you use the extension function get. You just create it here, right? So this pattern, as I already mentioned, is widely used in Kotlin's libraries, and we can read more here about extensions. It says that provides the ability to extend a class or an interface with new functionality without having to inherit from the class or use design patterns such as decorator. Okay, this don't be a special declarations called extensions. Interesting. For example, here we have, what is this? You know that the first thing after the font reserved keyboard is the receiver type. This is a mutable list, right? Of type integer. Then we create an extension function which is called swap. Then we receive index 1, index 2, integers, and what we do is we save into a temporary variable this value of this index, and then we just do a swapping, right? This is the list itself, because list is what this is always what is on the left side, the receiver object actually, yeah. Then we have a list, 1, 2, 3, right? List that swap. So this list 1, 2, 3 is gonna be here, and we are swapping 1 with 3, right? Because this is the 0 index, and this is the 2 index. You can make it generic using generics here, and you can read along, and there are like more things. It says that it resolves statically at compile time, uh, depending on the receiver type. It calculates. What else? You can read, and this is pretty interesting, I believe, to mention. Yeah, that's it.